Claude AI agents transform static prompts into dynamic, autonomous workflows that execute complex tasks. They combine large language models with tool use, memory, and reasoning to solve real-world problems. By mastering these foundations, you can build systems that work independently alongside you. The Claude Agent SDK provides a native Python framework to construct production-ready agent loops. It handles the complex orchestration of tools, prompts, and streaming responses automatically for you. You can build powerful custom assistants by simply defining your tools and the initial query. The fundamental architecture relies on an asynchronous loop of thinking, acting, and observing. Each iteration allows the model to process new information and decide on the next logical step. This continuous cycle ensures that the agent adapts dynamically to changing contexts. An asynchronous agent loop streams results in real time instead of waiting for full execution. This allows your application to remain responsive and process intermediate tool outputs instantly. You can easily build dynamic user interfaces that reflect the agent's live thought process. Multi-turn sessions preserve the conversation history across multiple interactions and tool uses. This memory allows the agent to refer back to previous files or context without repetition. You use session state to create interactive workflows that feel like a continuous collaboration. System messages define the core persona, rules, and boundaries for your autonomous agent. They act as the foundational instructions that prevent the model from drifting off task. A well-crafted system prompt ensures consistent, secure, and highly focused outputs in production. Subagents are specialized Claude instances spawned by the main agent to handle focused tasks. They operate in isolated contexts, which prevents prompt leakage and strictly enforces the principle of least privilege. You can use them to efficiently parallelize complex workflows into manageable pieces. Task delegation allows the primary agent to break down a massive goal into smaller milestones. The main agent simply assigns these milestones to specialized subagents and waits for their finalized outputs. This architectural pattern keeps your overall system highly modular and easy to debug. Isolated context guarantees that a subagent only sees the specific data it needs to succeed. This prevents the AI from getting confused by irrelevant information from the broader conversation. You implement this to drastically improve accuracy and security on sensitive subtasks. Parallel execution enables multiple subagents to process different independent tasks at the exact same time. The SDK manages these concurrent operations, saving significant waiting time for the end user. This is the key to scaling complex research or coding tasks efficiently. SDK tooling equips your agent with both built-in utilities and custom functions to interact with systems. It bridges the gap between text generation and actual execution of real-world scripts. You leverage these tools to transform Claude from a chatbot into an active worker. Built-in tools include ready-to-use functions like file reading, writing, bash execution, and web searching. You simply grant the agent access to these tools without writing any complex implementation code. This allows you to prototype powerful capabilities in just a few minutes. Custom decorators allow you to turn any Python function into an agent-accessible tool instantly. By simply adding a specific tag above your function, the SDK automatically registers it for Claude. This makes integrating your proprietary business logic incredibly straightforward and clean. Safety hooks intercept every tool call before it actually executes on your local machine. You use these hooks to log actions, require human approval, or block dangerous commands entirely. This is absolutely critical for deploying autonomous agents safely in production environments. Tool use combined with the Model Context Protocol allows Claude to access standard external data sources. It creates a universal language for AI models to securely interact with external tools and APIs. You implement MCP to eliminate custom integration code for every new service. The Model Context Protocol standardizes how AI agents communicate with local and remote servers. It replaces chaotic, custom-built API integrations with a single, highly secure communication architecture. This lets you connect Claude to tools like GitHub or Slack effortlessly. External integrations allow your agent to fetch live data from third-party platforms autonomously. By running an external server, Claude can pull calendar events, emails, or repository issues directly. You use this to build assistants that seamlessly navigate your entire software stack. In-process servers run directly within your application's memory rather than as separate standalone programs. This completely removes network latency and simplifies deployment architectures for custom tools. You should default to in-process servers for internal utilities that require maximum execution speed. Context management handles how external data is fed back into the model's active working memory. It ensures that large responses from external tools do not overwhelm the limited context window. Proper context management keeps your agent focused and prevents expensive token limit errors. The code execution tool allows Claude to write and execute scripts within a secure environment. It provides a sandbox container where the AI can test code, analyze data, and run system commands. You enable this so Claude can verify its own logic before returning answers. A sandboxed environment isolates the agent's code execution from your host operating system completely. This prevents accidental data deletion or malicious scripts from compromising your personal computer. You always execute AI-generated code in these secure containers to maintain strict system integrity. Bash command execution lets the agent interact directly with a virtual terminal using standard Linux commands. Claude can install packages, navigate directories, and manipulate files exactly like a human developer. This capability is essential for agents tasked with complex software engineering duties. Data analysis output allows the agent to process complex CSVs and render mathematical visualizations automatically. Claude can write a Python script, execute it, and return the resulting insights directly to the user. This turns the agent into a highly capable, autonomous data scientist. The Computer Use API gives Claude the ability to visually perceive and interact with a graphical desktop. It translates pixels on a screen into actionable elements that the model can click or type into. You use this for automating legacy software that lacks a traditional API. Screen perception allows the agent to look at screenshots and understand the current state of a UI. Claude can identify buttons, text fields, and error messages visually just like a human operator. This visual context is critical for navigating complex, non-standard desktop applications. Mouse control enables the agent to calculate specific screen coordinates and simulate physical mouse clicks. Claude mathematically determines where a button is located and directs the cursor to that exact spot. You leverage this to script interactions across deeply nested GUI menus. Keyboard emulation allows the AI to simulate human keystrokes to input text or trigger shortcut commands. The agent can seamlessly type emails, fill out forms, or execute macro combinations autonomously. This perfectly mimics human data entry speeds for highly repetitive administrative tasks. Claude Cowork is an AI desktop assistant designed to handle autonomous knowledge work natively on macOS. It utilizes computer vision and local file access to execute multi-step workflows without user supervision. You use it to automate tedious daily administrative and analytical tasks completely. The core capabilities blend deep reasoning with actual hands-on control over your local file system. It acts as an autonomous worker that accepts a high-level goal and figures out the execution steps. This fundamentally shifts your role from doing the work to managing the AI. Autonomous task execution means you describe an objective and walk away while the AI works. The agent independently plans the steps, encounters errors, and corrects them without demanding your input. This enables you to multiply your personal productivity by running tasks in the background. Direct file access grants the agent permission to read and organize documents straight from your hard drive. There is no need to manually upload files into a chat window anymore. You use this capability to instantly synthesize massive local project folders into coherent reports. Subagent coordination breaks large objectives into distinct subtasks assigned to parallel AI threads. The main cowork brain orchestrates these smaller agents to format documents and analyze data simultaneously. This heavily reduces the total time required to complete massive, multifaceted desktop workflows. Vision and perception empower the assistant to comprehend standard desktop applications visually. It takes continuous screenshots to evaluate its progress and verify that actions were successful. This feedback loop ensures the agent does not click blindly if an interface changes unexpectedly. UI element recognition allows Claude to reliably find icons, menus, and text boxes across any software. It uses advanced spatial understanding to map out the application interface accurately before taking action. This guarantees the AI clicks the correct submit button even if the layout shifts. Screenshot analysis provides the agent with immediate visual confirmation of its previous action. If a window fails to load, Claude sees the error visually and can adjust its strategy immediately. This makes the autonomous agent highly resilient to system lag or unexpected pop-ups. The visual feedback loop creates a continuous cycle of acting, seeing the result, and planning the next move. This mirrors how humans naturally interact with computers, constantly adjusting based on visual cues. You rely on this loop to ensure the agent executes robust and error-free workflows. Automation workflows represent the practical, everyday tasks that Claude Cowork can take off your plate. They range from inbox management to compiling complex data from multiple spreadsheet files autonomously. Implementing these workflows frees up your schedule for high-level, creative, and strategic thinking. Meeting preparation involves the agent automatically reading past agendas and compiling relevant notes before a call. It can extract action items and synthesize background research into a clean summary document. You use this to enter every meeting perfectly prepared without spending hours reading. Data processing allows the agent to ingest messy spreadsheets and apply complex formatting or formulas. Claude can clean up raw CSV exports and generate highly polished, professional Excel reports autonomously. This completely eliminates the need for you to perform tedious manual data entry tasks. Email management enables the assistant to read your inbox, categorize messages, and draft contextual replies. It learns your communication style and handles routine inquiries without requiring your constant supervision. You simply review the drafted responses at the end of the day and hit send. Claude artifacts turn normal chat conversations into live, interactive workspaces for code, design, and documents. They render specialized files in a dedicated side panel so you can preview them immediately. You use artifacts to rapidly prototype fully functional mini applications without leaving the chat interface. Renderable types dictate what kind of interactive content Claude can display in the dedicated preview panel. This ranges from highly interactive web components to static architectural diagrams and professional documents. Choosing the correct type ensures the output is both usable and visually appropriate. React components allow you to generate stateful, interactive user interfaces directly within the chat window. Claude can build calculators, games, or complex forms that react immediately to user input. This is perfect for testing software concepts before moving them to a real codebase. SVG graphics let Claude create highly precise, scalable vector illustrations and geometric technical diagrams. You can view the visual output alongside the raw markup code and ask for specific design tweaks. This is incredibly useful for generating fast UI mockups and clean architectural icons. Mermaid diagrams transform simple text descriptions into complex flowcharts, sequence diagrams, and mind maps automatically. When you update the prompt, the visual diagram dynamically re-renders to reflect the new structure. You leverage this to map out complex system architectures and business processes visually. HTML web apps provide a classic structure for rendering full landing pages and interactive dashboards visually. Claude writes the HTML, CSS, and JavaScript together to create a cohesive, single-file application prototype. This allows marketers and developers to immediately see and test complete website designs. Advanced features elevate artifacts from simple visual previews to highly robust, stateful micro-applications. They enable data persistence and API connections, bridging the gap between a demo and a real product. You use these features to build tools that actually remember user inputs over time. The Persistent Storage API allows an artifact to remember user data across completely different chat sessions. You can build a habit tracker prototype that actually saves your daily progress when you close it. This transforms temporary prototypes into genuinely useful, long-term personal utility applications. The Claude API lets your interactive artifact make its own internal calls to the Anthropic API. Your mini-app can suddenly generate text, summarize inputs, or grade quizzes dynamically using AI reasoning. You use this to build intelligent microtools that leverage LLM logic under the hood. Live Artifact Refresh allows dashboards to pull in real-time data from external sources whenever they are opened. The artifact uses MCP integrations to connect to your live calendar or database automatically. This provides you with an always accurate, visually appealing control center for your daily operations. Practical applications represent the immediate, high-value tools you can generate using the Artifacts feature today. They span across multiple industries, helping educators, developers, and product managers work significantly faster. You apply these patterns to stop manually coding simple tools from scratch. Interactive dashboards take raw CSV data and instantly render it into beautiful, filterable charts and graphs. Claude analyzes the dataset and writes the React code to make the data highly explorable. You use this to present complex analytics to stakeholders without needing complex BI software. Educational quizzes combine structured learning material with interactive, self-grading HTML interfaces for students. Claude generates the questions, tracks the user score, and provides instant feedback on wrong answers. This allows educators to rapidly deploy engaging study materials without any programming knowledge. Landing page prototypes can be generated by simply uploading a rough sketch or describing your product vision. Claude writes the styling and layout code, providing a live preview you can tweak conversationally. This allows founders to validate business ideas visually before hiring an expensive design agency. Agentic coding workflows fundamentally change software development from manual typing to AI-assisted architectural design. You guide the agent with natural language while it handles the boilerplate generation, refactoring, and debugging. This approach requires you to focus on rigorous specifications and robust testing environments. The Claude Code CLI is a terminal-based tool that brings autonomous agent capabilities directly to your codebase. It can independently navigate files, execute bash commands, and run your tests to verify its own code. You integrate this to solve complex, multi-file software engineering tasks locally. Codebase navigation allows the CLI tool to grep through your entire project to understand system architecture autonomously. It finds relevant functions and traces dependencies without requiring you to paste code into a browser. This ensures the AI always has the perfect context for large-scale refactoring. Autonomous refactoring empowers the agent to rewrite legacy code across multiple files while maintaining existing functionality. Claude will analyze the architecture, propose a cleaner pattern, and execute the changes sequentially. You use this to rapidly clear out technical debt without burning hours of manual labor. Git integration lets Claude autonomously commit its changes with perfectly formatted, descriptive commit messages. It keeps atomic records of the agent's progress, allowing you to easily revert if the AI makes a mistake. Strict Git discipline is absolutely essential when letting an agent modify production code bases. Vibe coding is an intuitive workflow where you generate functional prototypes using purely natural language interactions. You iteratively converse with the AI, letting it write all the code while you act as the director. This allows non-technical founders to build impressive MVPs strictly through conversational guidance. Natural language specs serve as the foundational blueprint before the AI writes a single line of code. You must clearly document the architecture, edge cases, and user flow in plain English first. A highly detailed specification completely eliminates hallucinations and ensures the agent builds exactly what you want. Iterative prototyping involves asking the AI to build the application in small, testable milestones rather than all at once. You review each milestone, provide feedback, and let the agent refine the implementation continuously. This methodical approach guarantees the final product remains stable and perfectly aligned with your vision. Automated testing is the critical safety net that ensures AI-generated code actually works in a production environment. You must prompt the agent to write robust unit tests alongside the application logic. Without a strict test suite, agentic code can easily break downstream systems without you noticing. System prompting establishes the exact persona, constraints, and operational guidelines for your coding agent. A strong system prompt heavily reduces errors and enforces your preferred architectural patterns from the beginning. You must design these prompts carefully to guarantee the AI acts like a senior engineer. Role definition tells the AI exactly what kind of expert it needs to emulate during the session. You define its core competencies, such as demanding it acts as an expert in React and Tailwind. This psychological framing dramatically improves the quality and formatting of the generated code. Output constraints strictly define what the AI is not allowed to do, preventing lazy coding habits entirely. You can explicitly forbid it from using placeholder comments or rewriting unrelated portions of the script. Enforcing these rules ensures you get complete, production-ready code blocks you can easily copy. Security reviews force the agent to pause and deeply analyze its own code for potential vulnerabilities. You instruct the AI to generate a security assessment before finalizing any critical authentication or database logic. This proactive measure prevents dangerous exploits from sneaking into your final production application. Advanced decision-making tackles the problem of LLMs struggling with complex, multi-step tasks that lack immediate feedback. By implementing search algorithms and Q-value models, agents can evaluate the long-term success of an action. This completely shifts the AI from reactive guessing to strategic, forward-thinking planning. Reasoning frameworks force the AI to break down its thoughts before it executes a physical tool action. By vocalizing its logic, the model inherently produces more accurate and highly reliable decisions. You use these frameworks to prevent the agent from rushing into catastrophic, irreversible mistakes. The React methodology seamlessly intertwines reasoning traces with concrete actions in a continuous loop. The agent thinks about the current state, acts on it, and carefully observes the immediate environmental feedback. This fundamental pattern is the backbone of almost all modern, highly reliable autonomous AI systems. Chain of thought prompting explicitly requires the model to explain its step-by-step logic before providing an answer. This significantly improves the AI's ability to solve complex mathematical or logical routing problems. You implement this to make the agent's internal decision-making process completely transparent and debuggable. Self-reflection allows the agent to critique its own past mistakes and adjust its future strategy dynamically. If a tool execution fails, the AI analyzes the error message and formulates a new approach. This dynamic memory ensures the agent learns from failure instead of repeating the same broken action. Tree-based search allows the agent to simulate multiple potential futures before committing to a final path. It explores different branches of decisions, evaluating which sequence leads to the highest probability of success. You leverage this to solve incredibly complex tasks where a single wrong move causes failure. Monte Carlo tree search balances deep exploration of new actions with the exploitation of known successful paths. It plays out simulated trajectories to the very end to see if a specific choice ultimately succeeds. This dramatically enhances the agent's ability to navigate highly ambiguous or deceptive environments. Q-value models assign a specific numerical score to an action based on its likelihood of achieving the final goal. Instead of guessing, the LLM agent samples multiple actions and strictly chooses the one with the highest score. This completely eliminates the need for expensive trial-and-error backtracking during live inference. Step-level optimization trains the model to understand the specific value of every single intermediate action it takes. By learning from preferred and dispreferred choices at each step, the agent builds deep intuition for the task. This fine-grained training method creates vastly superior agents compared to simple outcome-based learning. Multimodal processing equips the agent framework to handle both complex text documents and visual inputs simultaneously. This allows the AI to synthesize presentations or reports that require a deep understanding of accompanying graphics. You implement this to automate workflows that are inherently visual, like layout design. Text summarization uses LLMs to extract the most critical metadata and conclusions from massive input documents. It distills chaotic information into clean, highly structured formats that downstream agents can easily process. You use this to feed strictly relevant context into your code generators, saving massive token costs. Image captioning employs vision language models to interpret charts and graphics into highly descriptive text labels. It mathematically aligns the visual data with its exact reference point in the original source document. This ensures that when the agent builds a final presentation, the images match the text perfectly. Iterative page review utilizes a vision model to visually inspect the final rendered output for aesthetic flaws. It catches subtle design errors like text overflowing out of a bounding box that code analysis misses entirely. This visual quality assurance guarantees the final artifact meets strict, professional human design standards.